Now start with second part, chapter 1, electric charges and field, class 12 physics, part second. First topic is continuous charge distribution. In continuous charge distribution, the region in which charges are closely spaced, charges क्या होंगे closely spaced, is said to be continuous distribution of charge. It is helpful to consider the density of charge distribution as we do for density of solid, liquid and gases, etc. First, in continuous charge distribution, linear charge density. In linear charge density, the charge is distributed over a straight line. चार्ज क्या होगा, स्ट्रेट लाइन पे डिस्ट्रीब्यूटेड होगा. सपोज वी हैव चार्ज डी क्यू एंड डी एल और ओवर द एज ऑफ द क्यूबोर्ड, देन distribution is linear charge density. Linear charge density is the charge per unit length. SI unit क्या होती है, C by M, where lambda is equals to Q by L or lambda is equals to dQ by dL. Then total charge on line L is equals to Q is equals to limit lambda dL. Second, surface charge density. In surface charge density, represented by sigma, charge is distributed over a surface area. Here we consider a surface area. Surface charge density is the charge per unit area. We have dq and ds. Sigma is equals to q by s or sigma is equals to dq by ds. Unit is c by m square. Total charge on s equals to sigma ds. Next, for volume charge density. In volume charge density, charge is distributed over a volume. Then the distribution is called volume charge density. It is the charge per unit volume. We are consider cuboid where dq and d tau. Here rho is equals to q by tau or rho is equals to dq by d tau. Total charge is q is equals to integration rho d tau. Next is electric field. In electric field is a region of a space around a charge or system of charge within which other charged particles experience electrostatic field. Means इलेक्ट्रिक फील्ड के रीजन अराउंड चार्ज के अराउंड जो रीजन होगा जिसमें क्या है, कोई भी पार्टिकल एक्सपीरियंस करेगा इलेक्ट्रोस्टैटिक फोर्स. Electric field intensity, the force experienced per unit positive test charge placed at that point without distributing the source. Suppose putting positive charge, we have Q naught, force F. If we put negative charge, then we have plus Q naught and F, but direction of plus Q naught, or we can say that test charge is opposite to the force F. Then if Q is source charge, Q naught is test charge and F is force and electric field, then E is equals to limit delta T tends to 0 F by delta Q, or E is equals to F by Q naught, or E is equals to 1 by 4 pi epsilon naught Q by R square R vector. Then total charge considered very small, so it does not produce any on electric field. Then we can say that force experienced per unit positive test charge. SI unit is N by C and it is a vector quantity. Electric field intensity due to positive charge or point charge. In point charge, electric field intensity at P is 1 by 4 pi epsilon naught Q by mod R square R vector. Magnitude of the electric field at point P is given by mod cancel E mod is equals to 1 by 4 pi epsilon naught Q by R square. If Q greater than 0, then it is positive charge and E is directed away from source charge. If Q is less than 0, then it is negative charge and E is directed towards the source charge. Here E directly proportional to the 1 by R square. Now superposition principle. In superposition principle, the electrostatic force experienced by a charge due to other charges is the vector sum of electrostatic forces due to these other charges as if they are existing individual. Here we have charge plus q1 plus q2, and we have forces F12, F13, F14, F15 plus q4 minus q3 minus q5. Then F1 is equals to F12 plus F13 plus F14 plus F15. Okay. Now putting the values of F12 like 1 by 4 pi, 1 by 4 pi epsilon naught q1 q naught, or we can say that we have 1 or 2, then we can say that q1 q2 by r12 square, and so on. Then after combining, we can taking common 1 by 4 pi epsilon naught. Then we have summation p is equals to 1 b naught equals to a, and qa qb ra minus rb divided by mod ra minus rb cube. Okay. And for other examples, for 1 3 we have q1 q3, and 1 4 q1 q4, 1 5 q1 q5, as in r for f12 we have r12, and for f13 r13, and so on. Then last we are taking together 1 by 4 pi epsilon naught common, and putting these values, then we get summation qa qb ra minus rb divided by ra minus rb cube.